In this lesson, we'll be looking at the addition and subtraction of sets. And if you have not subscribed to this channel, kindly subscribe. That in case a video is being uploaded, you'll be the first person to be notified. Let's start. Now, the addition and subtraction of sets. We can only add or subtract sets which are alike or have the same form. This implies that if we have a set like m multiplied by square root of key plus n multiplied by the square root of key, we are saying that we can add these two based on the fact that the root components are the same. Now, if the root components are not the same, then we cannot add. So once they are the same, then we are going to add the coefficients, which means we have m plus n. And since the root components are the same, we write one of them, square root of key. That's the addition part. The same thing applies to the subtraction aspect. If you have m square root of key minus n square root of key, we are saying that provided the root components are the same, then we can subtract the coefficient and write one of the root components since they are the same. So now it means our solution now is m minus n square root of key. And this is the basic idea governing addition and subtraction of set. Now let's take this. If we have square root of p plus square root of q, can we add these two sets? No, because we can see that the root components are not the same, and henceforth we cannot say that square root of p can be added to square root of q, or better still, we cannot say that is equal to p plus q. Now, a typical example is what we have here, square root of 2 plus square root of 4. We cannot say that this is equal to square root of 6. No, because the root components are not the same. Not to talk of subtraction. That is, we having square root of 2 or square root of 4 minus square root of 2. Once the root components are not the same, we cannot say that is equal to 4 minus 2. That is the square root of 2. No, because the root components are not the same, you cannot carry on or continue with the operation sign. So this is the basic idea like we said earlier. Now let's try one or two examples governing the addition and subtraction of sets. Now in example 1, it says that we should simplify 5 square root of 3 plus 4 square root of 3, which means we have our question as 5 square root of 3. So let's write it well. So we have here as 5 square root of 3 plus 4 square root of 3. Now we are saying provided the root components are the same or they have the same square root number and square root sign, then we can add the coefficients, which means we have 5 plus 4. So we add the coefficient 5 plus 4 and we write one of the root component. And hence we have here as 5 plus 4 is going to give us 9. So that is 9 square root of 3. And that's the solution to this question. Now let's try question 2. It says simplify 5 square root of 5 minus 7 square root of 5 plus 4 square root of 5. Now we want to simplify 5 square root of 5 minus 7 square root of 5 plus 4 square root of 5. Now in this instance, we can see that the root components are the same. We have square root of 5 here, square root of 5, square root of 5. And once they are all the same throughout, then we can go ahead and add the coefficients. It means we are going to have 5 minus 7 plus 4. Then we bring the common root component. Now 5 minus 7 plus 4, we are going to get 2. And so at the end, you have 2 square root of 5. Now having known this, let's continue with the next set of examples. In example 3, we have simplify 6 square root of 3ab minus 2 square root of 3ab plus 3 square root of 3ab. I think we shouldn't shiver because at this point we can see a common root component, square root of 3ab, square root of 3ab, square root of 3ab. So it means we're going to add the coefficient, that is 6 minus 2 plus 3. And we bring our common square root component, that is 3ab. Now we know that 6 minus 2 plus 3 is going to give us 7. So at the end we have here as, that is 7 square root of 3ab. So this becomes our answer. Now in these questions we can see that they all have the same root component. Now what if they don't have the same root component, or they have not been reduced to their basic form? So our next example is going to explain to us situations like that. So in example 4, it says simplify square root of 147 minus square root of 75 plus square root of 27. Now in this instance we can see that these cells are not in their reduced form, but we have to add them. So with this we have to reduce them or write them in their basic form or reduced form so that we can continue with our solution. Now in this instance, if you have not watched our video on the reduction of set to basic form or simplest form, kindly watch out or kindly check it out. Now it means we have to consider square root of 147. Now in reducing square root of 147, then we have to consider the 147 itself. Now the 147, we have to find the factors of 147. And the factors of 147, we have 1, 3, we have 7, we have 21, we have 49, and 147. Now among these factors, we check out for the largest possible perfect square number, or the largest perfect square number. And among this, the perfect square number here we have is 49. And 49, we ask ourselves what number when multiplied by 49 gives us 147. But this number must come from the factors of 47, and that is 3. And so 3 is a non-perfect square number, and when 3 multiplies 49, we are going to get 147. So in simply put, it means 147 now is going to give us 147 is going to give us 49 times 3. So if now we are saying we have square root of 147, then we are going to get square root of 49 times 3. So let's put that one there. Now we continue. Square root of 75 is also not in reduced form. So with that, we have to find the factors of 75. Now the factors of 75, then we are going to get 1, we have 3, we have 5, we have 15, we have 25, and the last one here as 75. Now among the factors of 75, you have to look for the perfect square numbers. And the perfect square numbers we have here, we have 25 here. So that's the largest perfect square number here. But if there were 2 or more, we would have also considered the most largest. Now we ask ourselves, what number among the factors of 75 that when multiplied by 25 we're going to get our 75? And that number here is 3. So when 3 multiplies 25, we are going to get 75. And clearly we can see that 3 is a non-perfect square and 25 too is a perfect square, which means our 75 now is equal to 25 times 3. So if now we are saying that we have square root of 75, then we should get square root of 25 times 3. That is all square root. Now the next one is 27. So square root of 27 is also not in reduced form, which means we have to find the factors of 27. And the factors of 27, they are 1, 3, 9, and 27. So among these factors, now we ask ourselves, which one is a perfect square? And that one, we can consider 9. So 9 is a perfect square. And what number, when multiplied by 9, is going to give us 27 among the factors of 27? And that number is 3. So which means that 27 is equal to 9 times 3. If now we are saying that square root of 27, then we should have square root of 9 times 3. And this is how we can reduce square root of 27 and the other numbers to their basic form. So this is a procedure. So we are going to do substitution to our question. And remember that for square root of 147, we said we have square root of 49 times 3, which means we are now going to have our final solution as, so square root of 147 is now known to be square root of 49 times 3 minus, now square root of 75, it was found to be square root of 25 times 3 plus, now square root of 27, we also find out that is now 9 times 3. That is square root of 9 times 3. Now this implies that the square root is going to affect every number under the square root sign. So which means you're going to have, there should be an equal to here. Square root of 49 times square root of 3 minus square root of 25 times square root of 3 plus square root of 9 times square root of 3. In order to make it nice and not to confuse anyone, you can put it in brackets. Good. So with this, now we know that square root of 49 is 7. So we have 7, and 7 multiplied square root of 3, you're going to have square root of 3 minus square root of 25 is 5. So 5 square root of 3 plus square root of 9 is known to be 3. So we have here as 3 square root of 3. Now at the end, you can see that all the said has been reduced to their basic forms, and we can see that there is a common root component, that is square root of 3, square root of 3, square root of 3, and based on that we can add the coefficients. So we have 7 minus 5 plus 3, or square root of 3. And when we subtract minus 5 from 7 and add to 3, then we are going to get an answer of 5. That is 5 square root of 3. And this is our solution to the question. Now we continue with the next example. Now in example 5, we have square root of 50 plus square root of 2 minus 2 square root of 18 plus square root of 8. We want to simplify this. Now you can see that some of the said are in their reduced form and some are not. When we take square root of 50, it's not in its reduced form. Square root of 2 is in its reduced form or basic form. Now square root of 18 is not in its reduced form. The same thing applies to square root of 8. So with that, now we have to reduce square root of 50, square root of 18, and square root of 8 to their basic form. Now it means that we are going to consider square root of 50, and square root of 50 in its reduced form, we have to consider the factors of 50. And the factors of 50, we are going to have 1, 2, 5, we have 10, we have 25, and we have 50. Now among the factors of 50, we are going to consider the one that is a perfect square, and that is 25. Now among the factors of 25, which one when we multiply by 25, we are going to get 50, and that number is 2. So when 2 multiplies 25, we are going to get 50. So it implies that 50 now is equal to 25 times 2. Now, if you are saying that you want to find square root of 50, then we are going to have 25 times square root of 2. Let's put it there. Now, square root of 2 is in its reduced form, so we leave it. And we come and focus on square root of 18. Now, in reducing that, you have to consider the factors of 18. And the factors of 18, they are 1, and we have 2, we have 3, we have 6, we have 9, we have 18 itself. Now we ask ourselves, among the factors, which one is a perfect square? The only perfect square we have here is 9. So which number, when multiplied by the perfect square, that's going to give us 18. Now this number must come from the factors of 18, and that number is 2, which implies that our 18 is the same thing as 9 times 2. So if now we are saying 18, we have square root of 18, then we should have square root of 9 times 2. Now we put it there and focus on square root of 8. That is the last one. So now our focus is on square root of 8. And so you have to find the factors of 8. Now among the factors of 8, we have 1, 2, 4, 8. Now with these factors of 8, you have to look for a perfect square in the factors of 8. And that perfect square is 4. Now when 4 multiplies 2, you are going to get 8. And so we consider that, which means that our 8 now is equal to 4 times 2. This implies that if we have square root of 8, then we should have square root of 4 times 2. And this is a step for us to reduce square root of these numbers to their basic forms. Now we do a quick substitution into the main question, and for square root of 50, we are saying it can be expressed as square root of 5 times 2, which means square root of 25 rather. So square root of 25 times 2. Now we can put it in brackets, and then we maintain square root of 2 minus 2 in brackets. And for 18, we are saying we can have square root of 9 times 2, which means we are going to have square root of 9 multiplied by 2. And then for 8, we said we can express it as square root of 4 times 2, which means we have square root of 4 we have here as times 2. Now the square root sign is going to affect each number under the square root sign. So it means you have square root of 25 times square root of 2 plus square root of 2 minus 2 multiplied by square root of 9 times square root of 2 plus square root of 4 times square root of 2. Now, having known this, there's a square root sign here. So if that continues, then you know square root of 25 to be 5, and we have square root of 2 plus square root of 2 maintains the same thing, so square root of 2 minus 2. Now square root of 3 is going to give us, square root of 9 is going to give us 3. And we bring square root of 2 plus square root of 4 is going to give us 2. So we have 2 square root of 2. Now if that happens, then we can multiply the 2 by the 3 here, which means we have 5 square root of 2 plus square root of 2 minus 6 square root of 2 plus 2 square root of 2. Now we've been able to reach the point where we want to, and we can see that they all have the same radical component. So it means you can now add the coefficient. With the coefficient, the first one we have 5, and we know square root of 2 has a coefficient of 1, and minus 6, it continues to plus 2. We bring our square root of 2. Now 5 plus 1 minus 6 plus 2, we are going to get 2. So it means we have to get 2 square root of 2. And this becomes our solution to this question. Now we continue to the next example. Now in this example, it says that given that square root of 45 plus square root of 20 is equal to m square root of 5, find the value of m. And we can see that in this question, they are not in their reduced form. The square root of 45 and square root of 20 are not in their reduced form or basic form. So we'd have to do that in our solution, which means when we consider square root of 45, we have to find the factors of 45. And the factors of 45, we have 1, 3, we have 5, we have 9, we have 15, and we have 45. Now the factors of 45, we ask ourselves which one is a perfect square, and 9 is a perfect square. Now what number among the factors of 45 that when we multiply by 9 we are going to get 45? We can consider 5, because 9 times 5 is going to give us 45, which implies that 45 is the same thing as 9 times 5. So if you are talking about square root of 45, then we should talk about square root of 9 times 5. And with that, we can further reduce it, and we know that square root of 9, and we are going to have square root of 5, which means square root of 9 is the same as 3. So it means we are going to have 3 square root of 5. That is for the square root of 45. Now we do that for square root of 20, and for square root of 20, we are saying we have to find the factors of 20. And the factors of 20, they are 1, 2, 4, we have 5, we have 10, and 20. And we ask ourselves, among these factors, which one is a perfect square? The only perfect square we have here is 4. So what number must 4 multiplies so that we get 20? That number must come from the factors of 20, and that number is 5. Now we can confirm our solution as 20 is the same thing as 4 times 5. Now this implies that if we have square root of 20, then we should have square root of 4 times 5. And at the end, square root of 20 is going to be square root of 4 times square root of 5. Now we all know that square root of 4 is going to give us 2, which means we have 2 square root of 5 to be equal to square root of 20. Now, having been able to reduce the set to their basic form, we do substitution. And when that happens, our original question, its solution now becomes, now we said square root of 45 plus square root of 20 should be equal to m square root of 5. Now we all know that square root of 45, its reduced form was 3 square root of 5. So we do substitution and we have 3 square root of 5 plus, now the square root of 20, we had an answer of 2 square root of 5. So we do that quick substitution, 2 square root of 5, which is equal to m square root of 5. Now with this, we can see that we can add the coefficients of the set since they all have the same radical sign, or the radical number square root of 2 square root of 2. It means we can now add 3 plus 2 whole square root of 5, and at the end we have m square root of 5, which implies that we have 5 square root of 5 to be equal to m square root of 5. Now you can see that when we compare these two numbers, we can see that our square root of 5 is the same thing as the square root of 5, and the only number left here is 5. So by comparing, you can see that by comparing, by comparing, we can say that m is equal to 5. And that becomes the value of m. Now let's try the next set of examples. In example 7, it says find the value of p if square root of 50 minus square root of 200 plus square root of 98 is equal to p square root of 2. Which means these said are not in their reduced form. So we have to reduce them to their basic form or simplest form. Now, this is the case. You have to find the factors of 50 if you consider square root of 50. Then you have to find the factors of 50. And then among the factors, you identify the possible perfect square number and use that in our solution. That is a bit tedious and involving. And we have square root of 200. We have to do same, square root of 98. Now what if we have a whole lot of numbers, like square root of 75 plus square root of 27? Doesn't mean you have to find all these, their perfect square numbers and be doing that. So the simplest way is that if you have cases like this, or you want to go this in the short format, now in questions like this, at the end you are going to be given the reduced form in the equation. Now this square root of 2 is giving us a hint that when we reduce all this said, at the end we are going to have square root of 2 attached to it. So to make things so easy and simple, then we can consider these 2, which means we can divide 2 by 50. So considering square root of 50, then means we can divide this 50 by 2. Now let's use the red color, which means we can divide this 50 by 2. Now when 50 divides 2, we are going to get 25. So this means that when 25 multiplies 2, then we are going to get back our 50. That is the ideology. Now we are saying that we have square root of 50. Then it means we should get square root of 25 times 2. If and only if 25 times 2 gives us 50. That is for 50. Now it means this square root of 25 times 2 can be further reduced. But let's hold on and deal with the next one. With the next number, we are having square root of 200. So with square root of 200, considering the reduced form here, square root of 2, then we can divide 200 by 2, which implies that we can now have 200 divided by 2, which is going to give us an answer of 100. Now this is to tell us that if we multiply 100 by 2, then we are going to get back our 200. Now we are seeing square root of 200. So if you have square root of 200, then we should have square root of 200 should then be the same as square root of 100 times 2. Let's keep this and work on the other. Now the next number here is 98. Now with square root of 98, it means we have to divide the 98 by 2. And when 98 divides 2, then we are going to get an answer of 49. Now this is to tell us that if you multiply 49 by 2, then we are going to get back our 98. So if now we are saying we have square root of 98, then we should get square root of 49 times 2. And so these are a step to the reduced form. Now let's do substitution to our main question. Now in our main question, we are having square root of 50 minus square root of 200 plus square root of 90 is equal to p square root of 2. Now remember, for square root of 50, we said we have square root of 25 times 2, which means into bracket we have here square root of 25 times 2. And for square root of 200, we said we should have square root of 100 times 2. That is for square root of 200. And we do substitution, it means we have square root of 100 times 2 plus, now the square root of 98, we considered 49 times 2. Now let's check if that's correct. Yes, 49 times 2. That gave us square root of 98. Now we bring the p square root of 2. Now with this, we can see that square root of 25 times 2 is going to be affected by the square root sign each and every one of them, which means we are going to have square root of 25 times square root of 2, and we are going to have here as square root of 100 times square root of 2 plus square root of 49 times square root of 2, which is equal to p square root of 2. Now with this, we know square root of 25 is the same as 5 square root of 2 minus, now square root of 100 is the same thing as 10 square root of 2. We bring our square root of 2, and when we come here, you know square root of 49 is the same as 7, and we bring our square root of 2, which is equal to p square root of 2. Now having known this, we can see that they all have the same square root number, that is square root of 2, square root of 2, square root of 2, and square root of 2. Now with this, we add the coefficients, and that's we are going to get 5 minus 10 plus 7, all square root of 2, giving us p to be equal to square root of 2. Now 5 minus 10 plus 7 is 2 square root of 2, and at the end you have p square root of 2. So by comparing, you can write it as by comparing, then we can see that our p value here is equal to 2. So that is the value of p. Now let's try our last example. The last example we have, if square root of 24 plus square root of 96 minus square root of 600 is equal to y square root of 6, what is the value of y? So we can see that these sets are not in their reduced form, and we have to do that. Now when we come here, consider square root of 24, then you have to find the factors, and within the factors we find the perfect square, we multiply them like we did initially, and that's a bit involving. But we can see that there is square root of 6 here, that is the reduced form, which speaks to us that in any case when we reduce this set, we are going to get back a radical or a set of the form square root of 6. So if that's the case, then we can divide each and every radicand by 6. Now it means when we consider 24, then 24 divided by 6, then we should get an answer of 4. Now when 4 multiplies 6, then we're going to get back 24, which implies that 4 multiplies 6 should give us 24. Now if this ideology is there, then we continue. Now we are saying square root of 24, and we know that 4 times 6 is giving us 24. So if you have square root of 24, then we should get square root of 4 times 6. So which implies that our square root of 24 is going to be square root of 4 times square root of 6. Now square root of 24 is going to give us, now square root of 4 is the same as 2, and we have 2 square root of 6. So the reduced form for square root of 24 is 2 square root of 6. Now we continue, and the next one is what we have here as square root of 96, which means you can divide 96 by 6, and that's we are going to get 16. Now this implies that if 16 multiplies 6, then we are going to get back our 96. So now if we are saying that we have square root of 96, then we should get square root of 16 times 6. And we know that square root of 16 times 6 is the same thing as square root of 16 times square root of 6. Now we have square root of 96 here. So it means square root of 96 is the same thing as, now square root of 16 is 4, and we have here square root of 6. Now, let's see if you are done. You have square root of 600 left. Now, the last one, that is square root of 600. Now, square root of 600, you have to consider 600 and we divide by 6. And when 600 divides 6, then we are going to get 100. Now, this implies that if 100 multiplies 6, then we are going to get back our 600. So now, if we have square root of 600, then we should get square root of 100 times 6, which implies that our square root of 600 is equal to square root of 100 times square root of 6. Now we know that square root of 100 is going to give us 10, and we have our square root of 6. And these are the reduced form of the surd we have. So if we are to continue with our solution, then we can see that our solution now, square root of 24 plus square root of 96 minus, so let's write it all. That is minus square root of 600 is equal to y square root of 6. Now we know square root of 24, its reduced form is 2 root 6. So you have 2 root 6 plus, now the square root of 96, we know its reduced form to be 4 root 6. So you have 4 root 6 minus, for the square root of 600, we know its reduced form to be 10 root 6. So we write it as 10 root 6, giving us y square root of 6. Now, at this point, you can see that they all have a common radical sign, so we can add their coefficients. That is 2 plus 4 minus 10, or square root of 6, giving us y square root of 6. Now 2 plus 4 minus 10 is going to give us minus 4, and we bring our square root of 6. Now we have here as y square root of 6. Now if that continues, then we can compare and see that by comparing, we can see that our y value now here is equal to -4. So this ends our solution, and practically this ends to this video. And so thanks for watching. Kindly like, comment, subscribe, and share. This is Bakumat, thinking beyond infinity.